Standard form. This is the third way to write a linear equation. Any linear equation can be written in standard form. Even vertical lines, which cannot be written in the two previous forms that we have talked about. In standard form, we have ax plus by equals c, where a, b, and c are three numbers, any three numbers, positive, negative, fractions, decimals, anything like that, including zeros. Each of them can be zeros, although at least one of a and b must be non-zero. So they both can't be zeros, because then you'd be just left with c. Sometimes when you have an equation written in standard form, it might be helpful to actually convert that or change it to slope-intercept form, because when we have it in standard form, we actually can't visibly see the slope here when it's in standard form. And so you might want to, for some reason, maybe to graph it or to find, simply just to find slope. You may want to rewrite it in slope-intercept form, or vice versa. You might want to take something out of slope-intercept form and put it in standard form. So we're going to look at doing those two things in this video here. So in this first one here, we're looking at two steps to convert from standard form to slope-intercept form. We're going to use algebra to isolate our variable y. This goes back to a previous section from, I believe, chapter 3, where we were isolating variables within within equations. So the first thing I'm going to do is highlight the term that I want to keep on the side by itself. And in order to remind myself of what that term is, I'm going to rewrite my slope-intercept form, y equals mx plus b, and this allows me to see that y is on a side by itself. And so I want to start with having y, the term with the y by itself, which means that 7x needs to go. So I'm going to subtract 7x from both sides. And that's what it tells me to do here in step 1. I'm using inverse operations to make sure that x and y terms are on opposite sides. So I'm left with 2y equals minus 7x, or negative 7x minus 6. And notice that I put the 7x in front because that's how we have it for the slope-intercept form. And then the last thing I want to do, I do want y by itself, so I'm going to divide everything by 2. And I know that you might have the instinct to just do one big divide by 2, but that doesn't help me get my slope and y-intercept as two separate numbers. And so that's why I'm doing the two separate divide by 2s separately like that, because now I have y equals my slope, which is 7/2 x minus 6 divided by 2 is 3. And I'll do that one more time so that you can see another example of that. Once again, we want to isolate our y term. So the 16x needs to go to the other side using inverse operations. It's a positive 16, so we're subtracting it from both sides. And then I still want to isolate my y here. And so I will divide by 12, negative 12. And that gives me, let's see, I'm going to divide the 16 by negative 4 and the 12 by negative 4 to simplify these fractions. I want to keep it as a fraction because that's helpful, having slope as a fraction, when I'm graphing. So negative 16 divided by negative 4 is 4, and negative 12 divided by negative 4, it should be a negative 4, is 3. And notice this equation, my y-intercept is just 0. I had a 0 here, which gave me nothing here. And that is converting from standard form to y-intercept. But what if I need to go the other way around? Well, let's look at that. I'm going to write my standard form up here just to remind myself of what that looks like. Noticing that that x and y are on the same side this time. So if it's in y-intercept form, they're on opposite sides. I need to get them on the same side. So I'm going to use inverse operations to make sure x and y terms are on the same side this time. And this second step is kind of optional, but I like to do this second step because, who likes fractions? So doing this second step will get rid of our fractions so that we just have a nice clean standard form with whole numbers, no fractions. So since I want x and y on the same side, this time I'm actually isolating my constant or my number without a variable. So I'm isolating my 8, which means I'm going to subtract 9x from both sides because I want my x and my y on the same side. And notice I put the x first and then the y because that's how it is in standard form. And I'm done. There's standard form. Some people like to go a step further and make sure that, with the laser, make sure that the x value is positive. If that is something you're interested in doing, you could multiply everything by -1 and write an equivalent equation, giving you a positive a value. They are equivalent. This first one is just as much standard form as the second one is. They're just equivalent versions of standard form. And this next one, we're going to do the same thing. We're going to isolate our constant, which means I'm going to add my variable to both sides, my x variable. And if you didn't want to work with the fractions, you could actually get rid of the fractions in the first step. We practiced doing that in previous lessons. You could go ahead and get rid of the fraction and then put it in standard form. So you could do that. Technically, this is standard form. So technically, this is done and in standard form. However, if you wanted to go one step further and clean it up a little bit, getting rid of the fractions, we can multiply everything here by the LCD, which in this case is 7. So we're going to multiply by 7. And that will give me 7's cancel, 3x plus 7y equals 7. And once again, these are equivalent standard forms. They are both standard form for the same equation. When you graph them, you'll get the same line. And that is our introduction to standard form.